So dividing two fractions. Dividing two fractions is really just multiplication plus a step. Right, so all we're going to do here is we're going to do one extra step that takes this division problem, converts it into a multiplication problem, and then you do exactly what we were talking about in the last lecture. Multiply the tops, multiply the bottoms, check if you can reduce, and you're home free. Now, there's two different ways you can write a division problem with fractions, all right? And I've got both of them here. One is the one on the left with just the kind of the classic division symbol. And the other one, the one on the right, you write it as a fraction over a fraction, right? So it's a fraction of a fraction, if you will. These two expressions both mean exactly the same thing. All right, now, I think that especially for teaching purposes, the one with the division symbol, the one on the left, is actually the best way to go. Because there's a really simple little algorithm, if you will, that you can remember for doing this. And I actually was told this by some of my college students, just, I don't know, 4 or 5 years ago now. It's keep, change, flip. Right, so what this is saying, right, here's what you do. You keep the first fraction the same. You change the multiplication to division. That's what I told you we were going to do, right? Convert this to a multiplication problem. And you flip the second fraction over. You replace the fraction with its reciprocal, if you want to use fancy math language. And now, yeah, okay, great. Now it's just a multiplication problem. You multiply the tops. 4 times 2 is 8. You multiply the bottoms. 5 times 3 is 15. Can we reduce this? No. Nothing goes into 8 and 15. So that's it. Right, there's our answer. So how about this situation? This one might throw students a little bit because it looks like there is no second fraction. So, you know, they're thinking, well, how am I supposed to flip it over? Well, here's what we're going to do, right? That 2 really kind of is a fraction, right? You can rewrite it as 2 over 1, right? Because 2 divided by 1, that's just 2. I didn't change the number. It still represents the same value. But now you can see the fraction. So you can see what the flip is going to give us. So let's do this again. Right, work through the example here. I'm going to keep the 4/5 the same. I'm going to change the multiplication to division. And I'm going to flip the 2 over 1. So it's going to become 1 over 2, right, which is just 1/2. And now it's a multiplication problem. Right, so we're going to multiply across. 4 times 1 is 4. 5 times 2 is 10. And we're not done. Right? Remember, I've said this many times now. You always have to stop and check. Can I reduce this fraction? And we can with this one. 2 goes into both 4 and 10. So that gives me 2/5. That's going to be the final answer here. Okay, so that takes care of multiplication and division. Right? So we're halfway there. And that leaves us with addition and subtraction. Now, I know addition and subtraction just send some students into a tailspin, right? And I get it. I understand why. And I really do think that a big part of the reason is that teachers, middle school teachers in particular, bless their hearts, often make it more complicated than it needs to be, right? You do not need to find the least common multiple to add 2 fractions together. It is not necessary. It adds an additional complicated step, because you've got to refer back to that finding the least common multiple process where we're finding prime factorizations and counting. I don't know. You don't need to do that. All right, so jump ahead to the next video, right, and I'll show you how you can avoid that whole messy process.